Okay, so here's another example on the application of universal law of gravitation, but this time, let's make the assumption that planet X and planet Y would have the same mass. Okay, so I would say mx, and this one is the mass of Y. And let's make the assumption that both of them will be equal, m of Y. Okay. Now, the only thing that will be different this time is that the distance between the satellite and the planet, not the same, or not equal. So it's too obvious in our illustration that on planet Y, the distance between the satellite and the planet is smaller, and the mass again of this satellite is identical with each other, so therefore mass of m the same as m. Mx and my, so mx equals my, so we'll just say that we can just call it m uppercase M. Now the comparison is about your displacement. Okay, so the displacement, the distance. What if we're going to say that r is basically twice the distance of r? How strong or how weak is your force of gravity? So force of gravity of X, force of gravity on y-axis, between planet Y and the satellite, planet X and the satellite. So we can say that force of gravity between planet X and the satellite is stronger compared to the satellite and planet Y. So we can say it's greater than Fg of Y. Now, how are we going to prove it? Again, we can use the universal law of gravity, where it states that the force of gravity is equivalent to G, mass of the bigger object multiplied by the smaller object's mass divided by the square of the radius. Square of the radius. So therefore, we can start by plugging in the information that we have, and that is Fg of X is equivalent to G m times the smaller case m over the square of their distance. While the other force of gravity, the magnitude, can be calculated using the same equation, which is G multiplied by m over m divided by the square of its displacement, or the distance between the satellite and the planet, where in our case it's lowercase r. But we all know the relationship is that the uppercase r is twice the smaller case r. So we can change this value on our first equation for Fg of X, the force of gravity between the satellite and planet X. And let's substitute the value of m over, instead of using uppercase r, let's use the equivalent value, which is 2r, and then we square it. So therefore, we can further simplify it. That is G m over 4r squared. 4r squared. 4r squared. Let's isolate the value, or the constant value of 4, Fgx. Therefore, we can say that's 1/4 of G m over m r squared. And this whole value is basically equal to this value of 4Fgy. Therefore, we can say that Fg of X is simply equivalent to 1/4 of Fg of Y. So that's the effect of increasing the distance or decreasing the distance. By decreasing the distance by half, it will change into a fourth, which means it's a square of how much it was decreased. Okay, so hope this one will help you analyze what's the effect on changing the distance of two objects in terms of its gravitational attraction. See you in the next video.